Welcome back. This is a brand new series where we're going to develop from scratch a real-world engineering application. And we're going to be bringing together a lot of C# concepts to build this. We're going to be talking about random number generators. We're going to be talking about statistics. We're going to be talking about charts and histograms. We're going to be talking about a lot of user interface stuff that we'll need to do this. We're going to be talking about statistics and string builders and a whole bunch of stuff. So I encourage you to join us. This particular application we're going to develop is a simulator. And it's a simulator to simulate a network of temperature sensors. And this is part one, which is a project overview. And it's, in my view, the most important part of this series, where you look at what we're doing, why we're doing it, and how we're approaching it in the application. It will be very helpful when we finally start writing code to know what all the arrays are and what all the variables are and what we're doing, how we're approaching it. So I encourage you to watch this part one especially. Now, the reason for this is I'm working on another series where I'm trying to step through my understanding, improve my understanding of the science and the engineering aspects of the climate change discussion. If you're anything like me, you've not really felt comfortable in your understanding of what is arguably one of the most complex scientific topics around. And I've always felt a little bit uncomfortable that I don't really understand the science behind it. And from an engineering perspective, I like to see the actual facts and the numbers. And this is one attempt to answer one of the big questions I've had in trying to understand the climate change discussion. And this particular one was trying to understand how you can measure a global temperature using individual devices, a big network of individual devices, where each device is by itself relatively inaccurate. But the result of that big network of measurements is a highly accurate global temperature estimate. So that was my big question, and this is one way that I'm using to try and better understand that. So not only will we learn a little bit about C#, but maybe you'll, like me, learn a little bit more about climate science and help you to feel a little bit better in your understanding of how it all works. And honestly, I learned quite a bit on this. So now I feel much better about the concept of getting accurate temperature measurements. Still, there's more to do, but this is very helpful. So again, here's kind of a visual of how I'm approaching this. And you can see here I've got a bunch of temperature sensors, devices. And in this case, for this application, I'm starting out with an assumed 1,000 devices that I'm going to be measuring. And each device is going to give me a temperature measurement that is within a specified accuracy range. And in this case, I'm assuming each device has a temperature accuracy of plus or minus 2 degrees Fahrenheit. Now, where did I come up with that? Well, if you look at some of the common commercially available temperature sensors, generally they specify that their devices are in an accuracy range of plus or minus 1 or 2 to 4 degrees, depending on a number of different variables, like what temperature they're measuring and that kind of thing. And also, if you look at the NOAA, or National Oceanic and Atmospheric Administration, requirements for thermal sensors, they're generally in the 1 or 2 degrees Fahrenheit range. So I picked 2 degrees as a fairly common requirement for accuracy. It can change quite a bit depending on a bunch of different criteria, like where you install it and what temperature measure and that kind of thing. But we're just going to assume 1,000 devices, each with an accuracy of plus or minus 2 degrees Fahrenheit. And I'm also using assumption that they're measuring a temperature of 52 degrees Fahrenheit. The reason I chose that was kind of a coin toss, but if you look at the documentation of the papers, it appears that the belief is that in the last century, in the 20th century, the average global Earth temperature was about 52 degrees in the 20th century. So I'm just assuming an average temperature of 52 degrees, and if they have an accuracy of plus or minus 2 degrees Fahrenheit, that means they're all going to read somewhere between 50 and 54 degrees Fahrenheit. Okay, so I've got a bunch of sensors, 1,000 sensors, accuracy of plus or minus 2 degrees Fahrenheit, and I'm expecting they will read somewhere between 50 and 54 degrees, and I'm also assuming those will be relatively randomly distributed between those two, that be in that range, between 50 and 54 degrees. So what I'm going to do is I'm going to take 1,000 random readings, and then I'm going to take an average, which is going to be basically a daily average. So I've got 1,000 readings, I take the average of that, and I do another reading for the next day, take the average of that, and so on until I've done it for 1 year, 365 days. So I've got 365 averages, and then I take a final average of that to get a global average temperature from all of those readings. Okay, this is kind of a description of what I'm going to have in the code in the arrays to show you how it's going to work out. So for my 1,000 daily readings, I'm going to put each of those into an array of measurements. It's going to be called measurements. And these are all going to be 1,000 readings that are randomly distributed between 50 and 54 degrees, hopefully. That's the goal. So I've got, for this day, I've got a measurements array filled with 1,000 readings. And each day I'm going to take an average of those 1,000 readings and put them in another array, which is called measurements, measurements average. And that's going to have 365 elements, one for each day. So I do it the first day, I take an average, put it in the array. I do 1,000 readings for the next day with 1,000 other random measurements. I've got an average for that. So I build up 365 daily averages in this other array. And once this is all filled, I'm going to take an average of that array to get one average number for the year. And we're going to see if even if these are plus or minus 2 degrees Fahrenheit accuracy, will this final average be really close to our correct answer. Okay, so here's our application on startup, and you can see there's a bunch of stuff going on here. I've got a text box, I've got a couple of charts, I've got a lot of labels where we can output some of the data. Here you can see I've got the correct answer, which we decided we're going to use 52 degrees as the correct measurement. Here I've got a couple text boxes where the user can specify an accuracy. It defaults to plus or minus 2 degrees Fahrenheit. And also there's an area where the user can input bias, which is basically taking each measurement from each device and adding a certain amount of degrees Fahrenheit to it to give an overall bias so you can see how it affects the results. And then down here I've just got two buttons and also a picture box, but two buttons, an exit button and a sample devices button that starts the process of generating the samples and the averages and the charts. So if I press that, it goes through, and you can see here on the left I've got 1,000 random measurements from each of the devices, and here I've got all those numbers in histogram form. So 1,000 numbers in different bins in a histogram. So for example, we know it's going to be between 50 and 54 degrees, each of these measurements. So here's at the low end, between 50 and 50.2, I've got 60 readings approximately. And you can see that there's relatively uniform measurements or numbers of measurements in each range. So this is a way I can use to verify that my random number generator is giving me some relatively random readings. And down here I've got the distribution of averages of each of the scans. So before I said I've got an array of averages for each day. I've got 365 elements in the array, which represent the average of each of the day's readings. And that's basically the histogram form of that. And you can see that gives you a fairly uniform, what's called a bell-shaped curve, or a normal distribution. And it shows the averages are only between 52, in this case 52.1 maybe on the high end, and 51.9 on the low end. So you can see that even though we've got a 50 to 54 degree range of actual measurements, the averages come out to be much more accurate, 52.1 to 51.9. So you can also see up here I've got a maximum daily error, which is kind of just a text form of these high and low end ranges. Maximum daily error is about 0.1 degrees and minimum is minus 0.1. So you can see these plus or minus 2 became a plus or minus 0.1 pretty much. And then the 1 year average, which is the average of the daily averages, so the average of all of these comes out to 52.0009 compared to the correct answer of 52.0. So you can see that this kind of shows that if you assume, and that's a big assumption again, that you have a normal distribution, a normal or a uniform averages, uniform distribution of errors, you can get very close to the correct answer. And I can do it again. So what I do in the code is I overwrite the last one, and I can do this all over again for another set of 365,000 measurements. And you can see that it doesn't really change the 1 year average temperature very much. So that's basically what we're doing in this application. And in the next part, we're going to go into some of the, configuring the user interface. And then we're going to get deeper into the actual code, how we implement the random number generator and how we implement some of these other histograms and that kind of thing. So I encourage you to join us in the next part 2. And if you like this, please hit the like button and also subscribe so you can be informed about I've got quite a few upcoming videos I'm going to be posting. Thanks again and have a great day.